Before we start, my name is Ingolf, this is Harald from the Technical College in Oslo. As said, we are both, as you can see, wearing shirts with squares as comment to the ongoing debate in Hungary. Yes.
Right, thank you very much for having us. We will talk about how BIM can be a transformer of processes, both in the AEC industry and in the educational sector. What you can see here is a model of our classroom, and we thought that would be the most appropriate model to show when we are discussing how we think that education can be changed in the line of BIM. Our topic, we are said to be BIM as a transformer of processes. Our name, Ingolf Sundfør and Harald Selvær, and how BIM can be a game changer, both for the AEC industry and for the educational sector. When we look at the past, you can see a picture showing how draftsmen were producing blueprints back in the days. We find that this method of producing blueprints are in many ways adopted when we are taking the use of new technology and when we start using BIM. We find that many participants use BIM programs, they produce 3D models, but what they deliver in the projects and what they get paid for are 2D drawings.
And revisions.
And revisions, I come to that. That means that we, in many ways, stupefy our models. We have perfectly functional 3D models, but we deliver 2D PDFs in the end of the day. Another problem in the construction industry is what we refer to as a culture of claim. In the established contractual framework, income is generated every time there arises a need for a revision and that are not covered in the tender documents. In other words, the framework rewards the production of revised drawings and plans throughout the project. Furthermore, a contractor who on a regular basis experienced that the actual cost of the construction is far higher than that described in the documents makes the claim. That means that you are rewarded for your revision rather than rewarded for making a good model. There are no initiative for making a good model in many traditional contractual frameworks. So, how can we break this deadlock? How can we make the BIM models better, and how can we make the buildings better and more effective? I will talk about one example, and it's an example of a governmental client in Norway, which are building a new hospital. This hospital is situated in the city of Tønsberg. The hospital covers approximately 40,000 square meters, and the budget is Norwegian 2.5 billion kroners, which is equivalent to 250 million euros. Hospitals are widely regarded as the most complex building type you can undertake. And that means that when you are trying to make a BIM model of the hospital, it will be equally challenging. Furthermore, the governmental client has made some objectives for this hospital. They want to reduce the costs of this hospital with 10% compared to similar projects. They want to reduce time from startup to completion with 50% compared to similar projects, and they want to keep the amount of construction-related errors at 0%. These are lofty goals, and we are interested in seeing how they are to meet these objectives. I have put up 5 points on how they are approaching these objectives, and they all relate to BIM. First of all, they demand that the model is to be at a quality of level of detail 500 at the startup. and level of detail is how detailed the model is. And LOD 500 can be described as build. It means that the building, the solutions, the detailing is to be as it is finished before they start up. Secondly, the physical co-location of the project team, including the contractor, throughout the whole project. And the village site is organized as a big room, reference to integrated concurrent engineering. It means that if you are to be a participant in the Sundfør project, you are to stay in the same room for the time of the project, and talking with the other participants, from the architect to the contractor. The contracts are collaboratives, which means that they try to address the problem with claimantship. In order to take part in the project, you have to pass an initial test. The government client says, this is a test, we want you to deliver a model describing the quality in this hospital, so and so, and the architect and the engineer and the contractor delivers their IFC file and are evaluated, and it's thumbs up or thumbs down if they can continue to take part in the project.
And by the way, the test is formed by one of our former students.
Yes. Secondly, an IFC file must be exported within 15 minutes from its proprietary BIM software. And what does that mean? Well, that means that the client demands collaboration on a specific topic or project area in the building within 50 minutes. If you have a large IFC file, a large project, pushing the Save As button to IFC can take hours. Which means if you have a problem you want to solve there and then, you can't wait for hours. The demand is you have to export that file within 15 minutes, because that is the dynamic of the collaboration on the projects. Well, I think these points are pointing in the right direction, how BIM can be changing the processes and changing the building industry. If you look back to the draftsman producing blueprints and take a look on the left-hand side, we see a classroom with added computers. IT added to the curriculum. I talked about how we, in some ways, copy the old methods when we have new technology. We are producing BIM models to some extent, but to a large extent we're just reproducing blueprints. And we think in many ways this is also the case when it comes to education. We add computers to our curriculum and hope that it will fix the problem. This is the situation that our students will be facing when they get jobs. This is a planning meeting of the Norwegian contractor Skanska. They are using interactive smart boards to discuss solutions in the model and finding solution as the meeting go on. So this is the actual situation where BIM is used as a center point in the projects. And this is the situation we need to prepare our students for. This is the environment they need to be productive under. So over to BIM and didactics. As I said, the model you have seen here is our classroom. This is a picture from the same angle as you can see on the computer here, and the Ingolf here sporting a checked shirt. We try to focus on activity rather than broadcasting. It has to be the activity of the students, has to be the source of the learning and what they end up with. And the question that we ask ourselves is, how can we make our students capable to perform in a model-centered environment? And we will try to address 4 topics which we have seen as vital in that area. First of all, I would like to make a quote on, from referring to the Brazilian educator, constructive educator Paulo Freire. He's been interpreted by Professor Michael O'Loughlin, who says on how learning emerges. Freire argues that curriculum must emerge from the generative themes of people's lives, and that if education is to be empowering, it must culminate in praxis. What does that mean for us? Well, the previous experience. Our curriculum is based on the students' previous knowledge and experience. Our students, we didn't mention that in the start, sorry, but our students are former construction workers, including carpenters, steelworkers, bricklayers, plumbers, and electricians. That means that our students has the practical understanding of at least one building discipline and is familiar with on-site construction. And we encourage our students to use this experience as a point of starting when creating their own models. And the ability to adopt previous experiences to a new phase in a construction site can be described as reflection in action. Secondly, we focus on what we call situated learning, learning-centered design, and empowerment. Ingolf.
Harald is in his trade originally a plumber, and I am a bricklayer, and the other teachers at BIM is carpenters, both of them. So we have found that the methods of situated learning, that is learning by a master apprentice vision, is very suitable for us, and it suits also the way to learn technological new things as we do with these former construction workers that we have.
Shall I go on? Yeah. Our classroom are transformed to what we call a knowledge reproducing environment, from a standard knowledge producing environment to a knowledge sharing environment. The layout of our classrooms encourages the teachers and the students to share experience, and we have large tables to give the student an opportunity to walk around and interact with each other. Secondly, in real life matters. We are talking about digital formats, we are talking about way to exchange communication, but in our experience, being together in the same room is of paramount importance. And referring to the Sundfør project, as I mentioned, where the demand from the government client is you have to stay in the same room, in the same site throughout the project, which means you can solve problem there and then, you can do follow-ups, and you can learn from each other as you go. And we see this in our classroom as well. Secondly, fourthly, is we establish collaborative arenas in our curriculum. We collaborate with the industry and the campus, and you can see Ingolf here smiling broadly while Veidekke, one of Norway's contractors, are signing a contract with our school. So that's important to us. Another arena of collaboration is internship. The students work for a period of time in different sectors and companies, and gain experience in that period of time. And thirdly, we have an alumni community which connects former students to both us as teachers and our campus. And here you can see an alumni meeting at a construction site discussing how BIM can be adopted on the construction sites. So 1 minute left, over to the conclusion. BIM is in the process of radically changing the established project structures. A much larger part of the overall project is moving forward to the pre-building phase, and subcontractors are expected to collaborate earlier and closer throughout the project. This means that BIM technicians need to be skilled in collaborative processes and digital holistic quality assurance. BIM is not an add-on, but at the heart of the project design. And learning-centered area design and learning-centered curriculum do not limit its use to topics involving BIM, but in our experience is that information technology and BIM profits from the use of these methods. Both the students' previous experiences and training, best described as situated learning, are key elements in the transformation that leads the former construction worker to play a vital role in the collaborative BIM projects. Thank you.